Sometimes when we're doing unit conversions, the units have exponents. So here's a couple examples. If you're looking at something in one dimension, that would just be a line. That could be meters, that could be inches. Two dimensions would be a square or a shape, just a two-dimensional shape, right? That's meters squared or inches squared. Three dimensions would be three-dimensional shapes like cubes. That'd be meters cubed, inches cubed. Well, what if you need to convert the unit in that particular dimension? In first dimension, we have just our regular conversions, right? 1 millimeter is equal to 10 to the negative third meters. But if that's a two-dimensional shape, or if we're just dealing with, an exponent of 2, then not only does it convert the unit, but it also converts the magnitude of the unit. So times 10 to the power of what? So first example, we have two dimensions, so our exponent is 2. And so when you square this, that gives you millimeters squared over 10 to the power of what? Well, when you're dealing with exponents, we would go negative third. Raised to the power of 2 would be like negative third times 2. So really, we're just going to say negative 6. And that would, since we're squaring it, that would be meters squared. When we cube something, we would say, okay, 1 millimeter cubed over 10 to the power of what? Negative third raised to the power of 3 is the same thing as you would multiply, so 10 to the negative 9 meters cubed. Now that gets a little complicated when we're doing unit conversions. First example of unit conversions. If we have 49 meters per second, we want to convert that to centimeters per second. That's not tricky. That's really simple because we don't have any exponents, and we've done this before. So we just need to find the relationship between meters and centimeters, and we know the conversion would be 1 centimeter is the same thing as 10 to the negative second meters. And can we cancel our units? Yep. Meters over meters. The only thing left over is centimeters and seconds. So this is a piece of cake because there's no exponent. But in the next example, we have 55 grams per centimeter cubed, and we want to get grams per meters cubed. So what's the relationship between centimeters and meters? Well, we know that 1 centimeter is equal to 10 to the negative 2 meters. But this is centimeters cubed, so we need to cube this whole thing. And when we do that, that gives us centimeters cubed, and that gives us meters cubed, and that's what we're looking for. Centimeters cubed would cancel right here. Centimeters, so that cubed would come inside, so it would be like this. So centimeters cubed would cancel, leaving us with grams per meters cubed. When we cube this, it also cubes our meters. Last example. You have newtons over coulombs squared times meters squared. Then we have, we're trying to convert that to millicoulombs times meters squared. What's our relationship between a coulomb and a millicoulomb? Well, every milli of anything is the same thing as 10 to the negative third. Since we're squaring this, we would square. And so when you actually do this assignment, you won't go in and rework your conversion factors. You'll just write it like that. Coulomb squared, Coulomb squared. That leaves you with a milli, Coulomb, meters squared, and then newtons.